Guten Tag again. Hello, hello. I am not German. I do not really know German, but I do know how to say good morning, and I know how to count. So I know German. Alright, so jump in, we'll say sudo DOS EMU. Okay, okay. I thought it was very important to show the commonalities and problems with DOS. Alright, and I thought it was very important to rant about the Windows operating system. Alright, because there's some unexplained things that happen that you may encounter that, in my opinion, are not necessary. Alright, I'm not going to fix it, okay, but I don't want anybody to get frustrated and dismayed because of something that they did not expect to happen. Just trying to explain that what I have found to have happened that slowed me up. Okay? Okay. I'm going to show you how to create a folder. Alright? Skip the hello world for today. Clear screen. We're going to go right into debug. No, we're going to go right into edit. Okay? We're going to edit. Let's see where we are. This is another thing too. By typing out the dir command, it shows you what's in your current directory. Okay? Or it could be like an ls. Now, ls is list for Linux, and on DOS EMU, ls is incorporated into here, so that's pretty cool. But if you're not using DOS EMU, you're using something else, DOS by nature does not come with the ls command. Okay? So I'm only going to try to stick to DOS specific commands here. Okay? Such as clear. Clear in the DOS EMU works. You can't type in clear on a regular DOS machine. Right? I made my own clear program, and I'll show you how to make one of those too, and it works out pretty cool. Okay, so let's type in dir, and we'll look around in here. Let's make a directory. Make directory. This does work in DOS. Make a directory, and say we'll call it today. Okay, we'll cd or change directory into today. Okay, okay. Let's type in dir. Of course, there's nothing in it. Now let's type in clear screen. CLS for clear screen. Okay, let's open up an editor, and this is what's going to happen. Oh, look at that. Why don't I have any keys? Why can't I move? Where's my cursor? Funkinalities. The funkinalities. Nothing. Okay. Okay. Because I only typed in edit. Let's say edit. Edit folder.asm. Okay. There we go. Okay. So now let's start out at address 100. Okay. And let's add in our RCX, where we're going to put the bytes. Alright, we're going to say at 300. Now let's make it 399 bytes big. Okay. Name, we're going to call it folder.com. That's going to be our executable file that we're going to make. We're going to say write, and then we're going to say quit. Okay. Don't go all the way. Don't go anywhere. You see my cursor? Don't go through all that. Don't leave an empty space here. Okay. I would assume that it would screw something up, but the system's so touchy. Okay. So it hits the quit. It actually hits Q and quits, but I don't like to put Q for my references. Okay. So that's what I do. Okay. Okay. We jump right in. Now we're going to move into the let's make some room. Move into the AH register, the opcode to create a file. Okay, which is 39. That's to create, not a file, but to create a folder. Now, these are something, tab, these are something here. 1 semicolon is a comment. You can comment out this line here. Okay, you can comment out what I'm about to say. What happens is, this gets read. Okay, this here gets hidden. This does not get read by the OS. Okay, or by the assembly interpreter or anything. Okay, or by the assembler. This does not get read by the computer, so you can hide stuff in here to actually say what you're doing. Okay, so we'll say opcode for create a folder. Okay, Now we go to the next line. And we will say, that's the opcode to create the folder. Now we'll move into the CL, or C register, low part of the C register, a 0. Okay? This is the type of folder that we want to create. Okay? As far as a writable folder, or one might be more restrictive, two is more restrictive. Okay? This here is just, we can read right to this folder. Okay? Now, we're going to move into the data register, the string of what we're going to call the folder, the name of the folder, okay? But remember again, this here 200 is not the name of the folder, but it is the memory address to where we're going to put the name of the folder, okay? Okay, now we'll say int 21 to put that in. We'll say int 20 to end the program, okay? Now we can come down here and we will say something like address 200, okay? Because this address here is going to locate, this address is going to be the location of the string that we want to name our folder as, okay? And let's say define bytes, comma, or tick tick. We're going to call it test folder, okay? Now, you encapsulate your string in your single quotes, okay? Now you have to terminate that with something, okay? And right outside of these single quotes, you want to put a comma and a space, okay? Comma, space, 00 to end that. If you did not put a 00 in there, you would get errors. And since this is not actually like a string that we actually write out to the screen as far as standard out, okay? If you remember with Hello World, we used 24 to write standard out, or we used a $sign. A $sign equals a 24 in hexadecimal, okay? So you can either enter in a $sign to end your string that you're printing out to the screen, such as a Hello World, or you can just end it with a 24, okay? But when you're writing something as far as standard input goes, or you're writing a file, or you're creating a file name, you're really not seeing it to the screen. You're doing something not at an interactive level, say. Okay, you're not doing it as a string of data. You're doing this to name an item or name something. Okay, and to do that, we will use the 00 terminator. Okay, and I'll go over that later, and you'll see exactly what I'm talking about later on. Now let's take this and we'll hit Control Alt. That'll bring us ready for menu option, and we'll hit down arrow, and we will say save. Okay, now hit Control Alt again, down arrow. Let's say exit now. Okay, if we look at dir now, we will see that our folder.asm file is located inside of there. Okay, and sometimes too, I want to let you know that when you hit dir, it'll just hang. It'll hang and hang and hang and hang, and about 2 minutes later, it'll come back and actually be able for you. Then you can actually type stuff down here. Okay, what'll happen is this here will go away, and your computer will seem to freeze. Okay. And I've shut down my computer many times after that and said, oh my god, what the hell just happened? Alright, but sometimes it comes through in about 2 minutes. Sometimes it doesn't come through in about 2 minutes. Okay? Okay. And you may notice that with not only the dir command, but some commands. You'll notice that, okay? Especially when you debug something, you run in debug or something, you'll run into an issue where it will just hang. Okay? Now, in order to take that source code file that we just made, and we want to run it through the debugger, okay? We want to say debug $sign space again folder.asm, okay? Now we could pipe this, send this back into a log file. I'm not going to do that yet. Let's just see what happens. First, let's run this, see if we get any errors. No errors. Dir. Okay, now we see that we have an executable file too, alright? So let's run that not only through the ASM, or let's run it through the debugger, and let's put it through my .log, okay? Let's put it in a log file, okay? Say dir. Now let's open the log file to read it, which is edit, we're going to use edit to open it, edit my log, okay? See here the address memory locations. This is what the debugger set it up as to be as far as the executable goes. Okay, that looks good. We'll look at that later. And let's then clear. Let's see if we can run executable, which was folder.com. Folder.com. Okay, executed properly. Dir. Okay, here we go. Alright, we just created our own folder with assembly language. Okay, test folder. Now let's pick it apart and look at exactly what we did. Okay, let's say edit my.log. Okay. What it did was it moved the assembler to 100. Now by natural state, by default, the assembler opens up at 100 anyway. But it's a good practice to tell your assembler where to start. Okay, because as you see down here, we moved the assembler to 200. Okay, you can assemble this at 0, 0 if you want to. That's no problem. You know, but it's a good practice to start using this quite often when you're writing this in like an editor. Okay, so you will see here, this is the code segment, okay, the location that we're at, and this is the data segment location. Okay, and we're say here, move into the AH register this number, which is 39. This number, like I said, is an opcode to create a folder. Okay, to create a file is 3C. In the previous tutorial I told you that 3C was to create a folder, but I had that backwards. Okay, and so this is now prepare for a folder. Okay, and then you have to give it something I would like to say is considered a parameter. Okay, what type of folder? Okay, if you were to insert this to be a 1, or if you were to make this a 1, then it would have restrictions to certain users or certain functionality to it. This is no restrictions at all. Okay, you can write to this, you can add files into it. You don't need any admin permissions to do that. Okay, and we also will be using, you notice here that this is the CL register. Okay, CL register, like I said before, contains not only the CX register contains not only CL, but it also contains the C high register. Okay, we could have written this maybe to a C high register. I'm not sure. I don't see why we couldn't have, but I chose to write it to a C low register. Okay, the segment of the register, the lower part of a register, or CX register. Okay, okay, and then you will see here now address 104, because our machine reads on a line. You see at address 104, we moved into the DX register. We moved into the DX register, and again, we used the whole DX register. We didn't use the D low or D high, which you can do that, but we used the whole DX register for this string of this address location. Okay, so we moved this string pretty much into here. Okay, or moved the address location of the string into that register. Okay, and that was what we wanted to name our folder. Okay, int21, remember int21 is BIOS specific only. Not BIOS, Jesus, is DOS specific only. There is int10, which is the same as int21, but is not specific to DOS. int10 is used by DOS and used by BIOS. Okay, but int21 is something that is used specifically by DOS. Okay, so later on we'll change over to an int10 type of execution. Okay, but this calls kernel. This ends program. Okay, interrupt 21. Say call the kernel, or do this, or execute this, or load this stuff, and then terminate. Okay, and like I said again, down here you can see how we then moved our assembler. We moved our assembler was stuck out over here at O10B. Okay, so in order to give us some room, we don't want to say assemble at O10B, because in the last, if you remember, we just had a source code file here. We don't really know where this stuff's going to end up. Okay, and it's not really important to know where it ends up. Now we can see that these seem to skip by 2s. Okay, okay, and however many bytes you add in there seems to, skip up by 2s. This one here is a little bigger, so of course that skips up by 3, but we really don't have to count all that out. Okay, unless we have problems like I showed you about jumps and everything else like that. But even that, sometimes after a while of dealing with those things, after that it becomes a little bit constrictive, but it's not so important that we need to actually count out each byte of data, each address line that we're dumping out. Okay, so we move our assembler up to 200. Okay, Now for some reason you can move an assembler up to 200 within an edit file or within a source code file, right? But when you're actually writing this stuff in the debug, jumping that far is not with a jump. Well, yeah, with a jump, but jumping that far. Certain jumps, what I want to say is certain jumps have certain limitations to them. A jump not zero has another limitation to it. This effectively can kind of be considered a jump, okay? And I'll show you more of that later. But in here, you have your defined bytes, and they are the name test folder, or the string of characters called test folder. This is a string, okay? But now, however, like I said, we're not writing this out to screen, okay? We're using this as a folder name. This is kind of like, you want to say standard in, okay? And it's not standard out. There's no notifications going on here. This is not saying hello world, okay? This is actually writing not to you, but to the computer, okay? So this is the name of our folder, and remember, if you're writing standard in, you want to terminate it with a 00 characters instead of a 24, or 24 equals hexadecimal $, okay? If you're not writing a string out, you need to put these 00 terminators at the end, okay? And after that happened, you see it went here. Now RCX was to write this to the CX register, say, or give it this much bytes, this many bytes, okay? We want to name it. We named it folder.com. .com is an executable format. Unlike Windows Windows machines, strict Windows machines where they have a exe format, this is a .com format. This executable, I don't believe, can be so big as exe, okay? The Windows exe format, or Windows exe suffix, can be a bigger type of file, right? But the .com suffix cannot be that big, okay? But it's okay for us right now for what we're trying to do, okay? So we named it, we wrote it, it gave us back some standard output that went into our log file here, which is writing 399 bytes, okay? And then we quit. Super. Control Alt down arrow. Exit. It has been saved. What did I save to it? I didn't save anything to it. Oh my god, do I have to use a mouse? Yes, I do have to use a mouse. You don't normally have to use a mouse. I think you could have got around that with the tab key to move it over, because I really don't like using a mouse. So that's what happened when we did our file. But look again. Our test folder is located in here. Can we dump, let's say, debug our .com file, folder.com. Okay, let's dump it out and look at it. That's the executable. Let's say quit, clear screen, debug folder.asm. No, folder.asm. Quit, debug folder.asm. Dump. Okay. This is our source code to what we have here. Let's follow the execution. See if we can follow execution. What address am I at? Instruction pointer is at 101. Okay, so this is the first instruction. Okay, first instruction says, this is not right. 0298. This is not right. Because I shouldn't have moved anything in there yet. Clear screen. Debug folder.asm. Oh, I'm doing it wrong is what I'm doing. Okay. I want to follow the execution of my machine. Okay. But I can't follow it through the source code execution. I need to follow it through the executable execution. So I'm going to say debug folder.com. Okay. Dump it out. Alright. Now let's say T. instruction pointer is now at 102. Let's take the instruction pointer RIP. Let's set the instruction pointer back to 100. Instruction pointer RIP 100. Of course, we can set our instruction pointer RIP. Okay, it's at 102. Let's set it to 100. Okay, enter. Okay, great. Now let's dump it out. Dump address 100. T address 100. And T address 102. Okay, that's not what I want to do. I want to say quit, clear screen, debug folder dot com. Okay, show execution, instruction pointers at 100. Let's say we're going to edit the instruction pointer, so it's at 100 now. Let's set it back to, or it's at 102. Let's set it back to 100. Now we're going to dump out 100. Okay, no, it's RIP. Our instruction pointer will have changed. No, it didn't change. See, it's erratic. Okay, sometimes it's erratic, and I'm going to tell you, frequent shutdowns are good. Frequent shutdowns are good, especially in the emulator, in the DOS hard operating system on a physical machine. Frequent shutdowns are good for you. Okay, because it seems like stuff gets stuck within at least 5 minutes. Okay, now we'll set the instruction pointer to 100. Now let's say T. Let's see what happens. Okay, our pointer went back to 102. Let's say T again for the next line of code. Okay. Now, I don't know what this is. I don't know what happened here. Okay, but at the 104 address, okay, where our instruction pointer landed on, now you can see that this is exactly what we typed, was move. You know what? I'm not going to settle for that. That's crap, because it should have debug folder .as or .com. Okay. Now let's say T. For some reason, it's starting at 102, even though I started at 101, and I don't know why that should happen. Because I want to show you before the move. See, if I keep it here, it's going to say that 39 is moved into AH, and it is moved into AH, but I want to show it before it has actually moved into AH, and that's a problem. RIP is at 102. I want to change the register, IP register. I want to change that to 100. Okay. Now let's show execution, and it's doing the same thing. Can we do execution of address 100? We can. I don't know what happened there. I think it did the whole thing. Okay. Quit, clear screen, debugfolder.com. Sorry guys, but we're not going to be able to see this move in there, okay? But this does move in there, okay? If you remember in our other file, alright, we started out, we had nothing, we had moved the assembler to 100, okay? And then at 100, we moved in this, so maybe this is the next instruction, maybe so, I don't know, okay? But we see that. Now take a careful look at the DX register, alright? The DX register has nothing in it. The CX register contains a 39, I don't know why it got thrown in there, but that's what happened, okay? So the next address, now we were at 102, okay? So now we're at 102, and the next instruction, or instruction pointer is going to, instruction pointer's at 104, right? Yeah. So 39. CX register. See, we entered into AH register, we moved 39 into AH, okay? Saying that's a folder coming. Then we gave the parameters of what type of folder we wanted to create. Alright. I don't know what this is. Maybe they should have, maybe they did not get zeroed out. I don't know, it's kind of hard to tell. Alright. But we do see here that the string of 0200, the address 0200 is ready for the DX register. So let's use T to trace that. Okay. Now we will see that the DX register contains the address of 200, or that's where our string's at. Okay, and we will see here that the AX register contains create folder. Okay, and the parameter to the folder, the permissions of the folder, will now be at C. I set it to CL and moved it to C high. Huh. It doesn't matter. It also do whatever it wants, right? But it works for us. Okay. So let's trace it again. And then, of course, we ran into the int 20. The program killed. And the program has terminated. The program has terminated. Okay? Okay. Now, let's say quit that. Clear screen again. And let's look at folder.com. Okay? And what we're going to do now is unassemble it. Okay? And this does not actually. Yeah, let's do that. If I hit R again, R again, R again, R for register, let's say register 104. Of course, okay. So quit. Clear screen. Debugfolder.com. Okay. Unassemble that. And we'll throw R at the bottom here so we can look at the registers. Okay. So this here, like I said, was moved into the AH register, the opcode for create a folder. Okay. Now move into the CL register. I did not put move into the CL register. Yeah, I did. I'm sorry, I did. Move into the CL register. No permissions. Permissions are okay, or unlimited. Not unlimited, but 777 permissions. Okay. Into the CL register. Okay. Then at address 104, we had move again. We moved into the DX register the address of 200, which is down here, some below this line here. We will not be able to see that. Okay. And we would see int 21, and that's program execute. Okay. And this here added some other stuff that is machine specific and what it did here. You can look at all this stuff when you write your program and everything else like that, and it's pretty cool. Okay. So our instruction pointer is at 100. This is what we're trying to do on the other analyzation of where stuff moves to the processor. The CX register, I don't know why the CX register contains anything right now. Right? I think maybe it could be because of other stuff, or maybe it was loaded into RAM. Okay. See, the instruction pointer now is at 100. AX register is empty and has nothing in it. Okay. If we use T, it'll put us to our next line of execution. Yes. Okay, but CL. I don't know what's not showing me what I need to do. Okay. Somehow magically AH got the folder command. Somehow magically. I don't know. Okay? But AX register changed. Okay? The AX register has a 39 in the high spot now. Okay? And somehow that happened. I think I could be a little backwards. Okay? And the CX register is still the same spiel. There's nothing in there. Instruction pointer, this is at 102. Our next command is to move CL 00 into CL. Now let's use the T for trace and see if that happens again. Okay. So the CX register has changed from 399. Okay. The 399 that was in there could have possibly been from the operating system already having something in there, doing RAM and all that stuff like that. And we will see that the CX register contains now 30. Actually, the CH register contains it, even though I put it in the CL register, the C low. Okay. So that's that. Flags. Like I said before, when you get a handler, I think it changes these flags. It'll change. These each individual ones are flags. Okay, they mean something, and I don't remember what they mean. But when you get a handler, which I'll show you probably in the next tutorial, when you get a handler, when you put something in the AH register and it sends back something, it'll store it in the A low, but then it'll also set a flag. okay? And you have to clear that flag, you have to move it or do something with it that's located there. Or if you write stuff to it, you'll overwrite it, okay? So you see here that we moved, or getting ready to move. Our next command is to move into the DX register the location of 200, okay? You can see it's empty right now, and if we hit T for trace, you can see now that the DX register is has the address location of 200 in it, okay? Okay. Now let's trace it again. Program terminated normally. That's that. That's that. Okay. Now, what I'm trying to explain is that we can see the individual processors being manipulated one step at a time. We can actually see our code going from certain areas to certain areas of the individual processor. Okay? Why am I unassembling at this address? I don't know. Okay? Let's go over it. Not one more time, but let's go over it and look at it again. Okay? D for dump. No. No. R for register. Okay. So like I said, this is great, right? It works when I don't want it to, or not expecting it to. We can see here, like I said, that we can see individual opcodes and slices of bits and data and things. We can see the processor the processor is alive, okay? With this slowed down version here, we can see how things are added to the processor, how the computer is writing, how the processor is handling information, what actual blocks right now on the physical device, or in this case a virtual machine, what physical blocks of the hardware the processor are being manipulated, okay? And this is at a step-by-step progression. We can see stuff being entered into the areas of our processor, okay? So that's that, and that's pretty cool. Minus all the DOS rant. Alright, so clear screen. I'm going to kill this now. Let me see if I can do a shutdown on this, huh? Yeah, right. Yeah, bad file name. Why? Yeah, if I do a, think about this. If I do a Control-Alt-Delete, now it wants to shut down my real computer. And no, I don't want to shut it down. You crazy? Alright. So, we'll just exit that window. And we will go sudo su. And clear psexit. We'll kill this video. Okay? Hope you guys are having fun. Having a super good time. 7983. Peace out. Catch you in the next one.